Hello guys and welcome to my channel. In this session, I want to talk about another technical process which is maintenance. Well, if you want to find out more about maintenance process, then don't miss this training session. Let's get started and as always, have a good one. The purpose of the maintenance process is to sustain the capability of the system to provide a service. Maintenance includes the activities to provide operations, support, logistics, and material management. Based on feedback from ongoing monitoring of the operational environment, problems are identified and corrective, remedial, or preventive actions are taken to restore full system capability. This process contributes to the system requirements definition process, architecture definition process, and design definition process when considerations of constraints imposed in later life cycle stages are used to influence the system requirements, architecture, and design. This slide is the IPO diagram for the maintenance process. The maintenance process includes the following activities. Prepare for maintenance. Plan for maintenance, including the development of the strategy that includes the following. Sustain service across the lifecycle in order to meet customer requirements and achieve customer satisfaction. The strategy should define the types of maintenance actions, preventive, corrective, modification, and levels of maintenance, operator, institution, factory. The various types of maintenance actions, including corrective maintenance, addressing failures or problems, adaptive maintenance, addressing changes needed to accommodate system evolution, perfective maintenance, addressing enhancements, and scheduled preventive maintenance, addressing routine servicing to prevent failures, while minimizing operational downtime. The approach to address logistics needs across the lifecycle, considering the following approach to manage spare parts or system elements, for example, number, type, storage, location, shelf type, conditions, renewal frequency. Analysis includes requirements and plans for packaging, handling, storage, and transportation. Anti-counterfeit approach, that is prevention of counterfeit system elements, especially parts in the supply chain. Identify or define sources of technical data and training needed to support maintenance. Identify or define the skills, training, qualifications, and number of personnel for maintenance. Consider any regulatory requirements that drive the need for specific skills such as safety or security. Feedback any maintenance constraints on the system or system elements to the system requirements definition, architecture definition, or design definition processes. Use the system analysis process to support any traits needed of the maintenance strategy and approach to ensure affordability, feasibility, supportability, and sustainability of the system maintenance. Ensure that the necessary enabling systems, products, or services required for maintenance are available when needed. The planning includes the identification of requirements and interfaces for the enablers. The acquisition of the enablers can be done through various ways, such as rental, procurement, development, reuse, and subcontracting. An enabler may be a complete enabling system developed as a separate project from the project of the SOI. Assign trained, qualified personnel to be maintainers. Perform maintenance. Develop maintenance procedures for preventive and corrective maintenance. Identify, record, and resolve system anomalies. Restore system operation after a failure. Plan future maintenance by reviewing and analyzing anomaly reports. Initiate analysis and corrective actions to remedy previously undetected design errors. per the identified schedule, perform preventive maintenance actions using defined maintenance procedures. Determine the need for adaptive or perfective. Perform logistics support. Conduct acquisition logistics actions includes performing trade studies and analysis to determine the most cost-effective means to support the system across the lifecycle. Design influence considers features that impact the inherent reliability and maintainability of system services contrasted with the affordability of other support options, including the use of spare parts. Design considerations are often constrained by availability requirements, the impact of supply chain management, manpower restrictions, and system affordability. Acquisition logistics plans for and develops strategies for system lifecycle supportability, maintenance, supply support, support equipment, staffing, and enabling systems concurrently with the definition of the system requirements. Conduct operational logistics actions. Operational logistics is the concurrent tuning of both the SOI and enabling systems throughout the operational life to ensure effective and efficient delivery of system capabilities. Operational logistics actions enable the system to achieve required operational readiness. The actions include staffing, maintenance, management, supply support, support equipment, technical data needs, for example, manuals, instructions, lists, training support, sustaining engineering, computing resources, and facilities. Operational logistics provides a rich source of data concerning the operational performance of the system. This data should be used to support trend analysis and provides a direct feedback loop on system effectiveness and efficiency and insight into customer satisfaction. Manage results of maintenance and logistics. Document the results of the maintenance process. Record anomalies observed during the maintenance process and analyze and resolve the anomalies, corrective actions, or improvements using the quality assurance process. Identify and record trends of maintenance and logistics actions. Maintain bidirectional traceability of the maintenance actions and the applicable system elements and system definition artifacts. Obtain feedback from customers to understand the level of satisfaction with the maintenance and logistics support. Maintenance is a term often used to refer to a phase during which the system is already operational and the primary activities are related to sustaining the capability of the system, system enhancement, upgrades, and modernization. In this context, the objective is to design the system from the start to allow for the possibility of maintaining value over the entire system lifecycle, thereby promoting value sustainment. Since operations and maintenance costs generally comprise a significant percent of total LCC, maintenance is an important part of the system definition, often linked to logistics, engineering, disposal, and environmental impact analysis. Maintenance helps ensure that a system continues to satisfy its objective over its intended lifetime. In that time frame, system expectations will expand, environments in which the system is operated will change, technology will evolve, and elements of the system may become unsupportable and need to be replaced. The COTS desktop computing environment is a case in point. Since the introduction of USB printers, it is difficult to find cables to support parallel port printers, for example. Maintenance is an integrated effort designed to address aging systems and a need to maintain those systems in operation. A maintenance program may include reengineering electronic and mechanical elements to cope with obsolescence, developing automated test equipment, and extending the life of aging systems through technology insertion enhancements and proactive maintenance. There are two main mitigation strategies that help users cope with the performance capability gap. A performance based logistics (PBL) approach known as performance based lifecycle product support and technology refreshment programs or TRPs. An open system architecture approach has been found to improve the ability to insert new capabilities, threat evolution, reduce development time, reduce maintenance costs, generate affordable cuts, obsolescence management, and increase human system integration. Open architectures enable a more capable, reliable, adaptable, and resilient system that accommodates continuous organizational and technology changes. The maintenance concept is an important lifecycle concept document. The following are recommended details that should be considered. Corrective maintenance. Processes and procedures for restoring system services to normal operations, for example, remove and replace hardware, reload software, apply a software patch, includes post maintenance test procedures to verify that the system is ready for operations. Time spent troubleshooting can be greatly reduced by well engineered diagnostic capabilities such as built-in test or BIT. Preventive maintenance processes and procedures for scheduled routine maintenance actions, for example, cleaning, filter changes, visual inspections, needed to sustain optimal system operational performance. System modifications processes and procedures intended to extend or sustain the useful life of the system or to provide new or to upgrade system capabilities. User or operator maintenance. Some routine and simple maintenance tasks are able to be performed by the system operators or users. Operator maintenance includes routine, for example, filter changes, recording data, and corrective, for example, software resets, install a ready spare, tire change tasks. In situation maintenance and report, sometimes referred to as field maintenance, maintenance tasks performed by a trained maintainer at or near the operational location. Factory maintenance, repair, and overhaul, sometimes referred to as depot maintenance. Major maintenance tasks that require advanced maintenance skills and special tooling or equipment not available at the operational location. The maintenance process includes other enabling systems that need to be considered that can be different from other processes. The following amplifies on these. Operational environment. The circumstances surrounding and potentially affecting something that is operating. For example, electronic or mechanical equipment may be affected by high temperatures, vibration, dust, and other parameters that constitute the operating environment. Supply support consists of all actions necessary to determine requirements and to acquire, catalog, receive, store, transfer, package, transport, issue, and dispose of spares, repair parts, and supplies needed to sustain required level of operations, for example, system availability. The reliability of the system is impacted when a maintenance action is delayed by the supply system. Training systems provides maintainers with knowledge and skills required for proper system maintenance. Technical data, procedures, guidelines, and checklists needed for proper maintenance of the system, including preventive actions, clean and adjust, analysis and diagnostics, fault isolation, fault localization, part lists, corrective maintenance, remove and replace, calibration, modification, and upgrade, instructions, post maintenance validation, etc. For systems with condition based maintenance or CBM capabilities, the technical documentation will include information on how those capabilities are used to support maintenance. Facilities and infrastructure. Facilities, for example, buildings, warehouses, hangars, waterways, and infrastructure, for example, IT services, fuel, water, electrical service, machine shops, dry shocks, test ranges required for system maintenance. Tools and support equipment. Common and special purpose tools, for example, hand tools, meters, and support equipment, for example, test sets, cranes, used to support system maintenance. Design interface sustaining engineering. Design interface attempts to design in supportability features of the system. Supportability considerations minimize the logistics footprint, maximize reliability, ensure effective maintainability, and address the long term issues related to obsolescence management, technology refreshment, modifications and upgrades, and overall usage under all operating conditions. Sustaining engineering ensures the continued operation and maintenance of a system with managed, that is, known risk. Activities include collection and analysis of use and maintenance data, analysis of safety hazards, failure causes and effects, reliability and maintainability trends, and operational usage profile changes. Root cause analysis of in service problems, including operational hazards, problem reports, parts obsolescence, corrosion effects, and reliability degradation, development of required design changes to resolve operational issues, and other activities necessary to ensure cost effective support to achieve required levels of readiness and performance over the system's lifecycle. Maintenance planning and management. The focus of the maintenance planning process is to define accessibility, diagnostics, repair, and sparing requirements, identify factors that impact the system's designed utilization rates, for example, maintenance man hour per maintenance action, maintenance ratios, identify life cycle supportability design, installation, maintenance, and operation constraints and guidelines, and provide level of repair analysis or LoRa. The following are some maintenance techniques that can be used for the system of interest. This is by no means an exhaustive list. Condition based maintenance or CBM is a strategy to improve system reliability by reducing the amount of time the system is unavailable while conducting routine or corrective maintenance. Well designed systems include the cost effective use of sensors, for example, airflow, vibration, thermal, viscosity, and integrated analysis based decision support capabilities to determine or predict the need for maintenance actions required to prevent a failure. System technical documents will include a description of any embedded condition based maintenance capabilities and how resultant maintenance actions will be performed. Reliability centered maintenance, or RCM, is a cost effective maintenance strategy to address dominant causes of equipment failures supported by failure modes, effect, and criticality analysis, or FMECA, and fault tree analysis, or FDA. It provides a systematic approach to defining a routine maintenance program composed of cost effective tasks that are serve important functions. SAE International provides detailed information on the RCM process. RCM is a strategy to improve system reliability by reducing the amount of time the system is unavailable while conducting routine or preventive maintenance. Performance based lifecycle product support is a strategy for cost effective system support rather than contracting for maintenance, goods, and services needed to sustain operations. The customer and the service providers agree on the delivery of performance outcomes defined by performance metrics for a system or product. When properly implemented, the provider is incentivized increased profits or contract extensions to develop sustainment strategies, for example, system reliability investment, inventory management practices, logistic arrangements necessary to meet the requirement performance outcomes at reduced costs. PBL approaches usually result in sustained performance outcomes at a lower cost than achieved under a non PBL or transactional product support arrangements for system material and maintenance.